On 7.1, you learned how to integrate pretty basic type problems and learning the formulas. Now you're going to learn how to do the chain rule backwards. You need to use the chain rule logs if it's an inverse. If it's a polynomial, if it's a trig function, and exponents. Integrate. So basically, this is what you did already. You did this, I think, in chapter 4. You learned how to take the derivative of sine, which is cosine. You left the inside alone, and then you took the derivative of the inside and got 2. Okay, so here are the steps. You have to let u equal the inside part. So this is how you want to do this, and you have to be able to recognize this on the AP test. This part right here is the derivative of that, 2x plus 4. So my inside part is u equals 2x plus 4. Okay, then once you figure out what your inside part is, you're going to find the derivative of that inside part. The derivative of 2x plus 4 is 2. You're going to get du alone by multiplying both sides by dx. After you get done doing this part, you're going to come over here and rewrite it. So you're going to put 2. You're going to put the cosine. You're going to resubstitute what the 2x plus 4 is. That stands for u. And I have to finish that. I guess I didn't finish it. And substitute what dx stands for. Dx is equal to du divided by 2. Okay, so you went from a very complicated problem to a more basic problem. So the rule says, well, I can cancel out the 2's too, because there's a 2 in the denominator and a 2 in the numerator. And all you have to do is take the antiderivative of cosine, and the antiderivative of cosine is sine u plus c. On the AP test, you do not have to put this back in if you don't want to. You could just leave it like this. Final answer. Okay, let's do another problem. Okay, let u equal x to the 5th. That's called the inside part. You have to be able to recognize the inside part of the chain rule. You're going to take the derivative of that inside part. You are going to multiply both sides by dx. You're going to get dx alone. And now when you're done with that, So you're using derivatives and integration all in the same problem. You're gonna set it up, and you're gonna put the little integral sign. You're gonna do the secant squared of u. You're gonna leave the 3x to the fourth, and you're gonna replace the dx with du over 5x to the fourth. The x to the fourth cancel out. 3/5 I can just put out in front. It's just a constant. The antiderivative of secant squared is tangent of u plus c. Final answer. If you want to replace the u, you can, but a lot of people just leave it. Let's do another one. Let u equal 5x plus 2, that's the inside part. Take the derivative of the inside part, which is 5. du is equal to 5 dx, so du divided by 5 equals dx. You always solve for dx. Once you get that done, you can make your integration sign. You're going to leave the 4. You're going to replace the 5x plus 2, so it's u to the 5th, and you're going to replace the dx with du divided by 5. You are going to have a 4/5 then on the outside. The antiderivative of u to the 5th is u to the 6th divided by 6 plus c with the 4/5. And that simplifies to 2u to the 6th over 15 plus c. Final answer. Okay, a couple more. We just keep doing kind of the same steps over and over again. Recognizing the u. The u is the part on the inside, 4x minus 1. Du over dx equals 4. So du divided by 4 equals dx. Kind of go a little quicker here. Put that, the inside part is the square root of u. In place of dx, put du over 4. But remember that this is u to the 1/2 power. Whoop. U to the 1/2 power. So if I add 1 to that, it's u to the 3/2 power. Divided by 3/2, which is the same thing as 2/3 u to the 3/2. But you have to make sure you put that 4 in there, which really makes 1/6 u to the 3/2 plus c. Okay, let's do this one. This is really the natural log of x, all of that squared. So the inside part is the natural log of x. The derivative of that is 1 over x. So x du is equal to dx. Squiggle. In place of the natural log, I'm going to put u and raise it to the second. There's also an x down there, but in place of dx, I put x du. So goodbye to the x's. U to the 3rd divided by 3 plus c. And if you want to replace the u as the natural log of x, you can do that. Okay, this one's a special one, because you have to kind of dig back into trig and know that tangent is the same thing as the sine of x over the cosine of x dx. There is no formula for the antiderivative of tangent, so that's why you change it, the sine of x over the cosine of x. You have to figure out which one is the u, the sine of x or the cosine of x. So this is what I would do. I would just try it. Well, u is equal to the sine of x, so du dx equals the cosine of x. So du divided by the cosine of x is equal to dx. But this would be on the bottom and this is also on the bottom, so this isn't the right u. So I'm going to go over here and pick u equal to the sine of x. Whoops, opposite one on that. Du dx. The derivative of cosine is a negative sine of x. Du divided by negative sine of x is equal to dx. Okay, let's see what happens here now. You make the squiggle, the sine of x over the cosine of x. Replace the dx with du over a negative sine of x. Sine of x cancels each other out. You're left with 1 over the cosine of x, or 1 over the cosine of u du, sorry. And remember that cosine of x is equal to u. Up above, the cosine of x is equal to u. It's the antiderivative of 1 over u, the natural log of u plus c. So if you want to replace it, it's the natural log of the absolute value of the cosine of x plus c, if you want to replace it with what u stands for. Okay, one more. Let's see if you know which one u is. Is u equal to 1 minus r to the third, or is it equal to 9r to the second? Which one is u? Well, it's got to be the one that's not the derivative of the other, and the derivative of this is 3r squared, so this has to be the u. Okay, so you're going to leave the 9r to the second. You're going to replace the square root of u. You're going to write what the negative 3r squared dr. Which gives you a negative 3 square root of u, but instead of doing the square root of u, I'm going to switch it to u to the 1/2 du, which is u to the 3/2 divided by 3/2 times a negative plus c. This is the same thing as 2/3 times a negative 3 u to the 3/2 plus c. It's going to end up being back it up. Sorry, made a mistake. This is the same thing as u to the negative 1/2, because I had to bring it up, du. Add 1/2, and I get u to the 1/2 divided by 1/2 plus c, which makes a negative 6 u to the 1/2 plus c, which makes a negative 6, and u is the same thing as the square root of 1 minus r to the third plus c. Okay, last template. I pretty much did the same thing over and over and over again. Now what happens when you actually have limits? So what do you do when you have limits? So here we go. We're going to let u equal 1 minus r to the second. du dr is equal to a negative 2r. du divided by negative 2r equals dr. Okay, so far it's the same. Okay, you're going to replace, you're going to leave the r, you're going to leave the square root, you're going to replace the 1 minus r squared with u. You're going to replace the dr with du divided by negative 2r. Divide to the r's. So now you have a negative 1/2 on the outside, u to the 1/2 du. From 0, okay, this is the tricky part. You are no longer working with r's, you are now working with u's. So since you are working with u's, you have to change your limits. 1 minus r squared, you need to plug 0 in, and you're going to get 1, and when you plug 1 in, you're going to get 0. Those are your new limits. You're no longer working in r's, so you have to change the limits also. So you're going from 0 to 1. And then you plug, you're going to leave it in the terms of the square root of u. You're going to plug the upper limit in first. And when you get the upper limit, you get negative 1/2 minus the lower limit, which is 0. Which ends up becoming I have to integrate still. It is u to the 3/2 divided by 3/2, which is the same thing as a negative 1/2 2/3 u to the 3/2, which is a negative 1/3 u to the 3/2. From 0 to 1, if you plug 1 in there, you get negative 1/3 minus 0, which is a negative 1/3. The tricky part is changing your limits. You have to make sure you change your limits. Let's do one more of these. Which one is it? Is tangent squared x or is it secant squared x? Which one is the derivative of the other one? You need to let u equal the tangent of x, because the derivative of tangent is secant squared x. Okay, I'm going to change it now. I'm going to change my tangent squared x to u squared. I'm going to leave my secant squared x. And dx is the same thing as du divided by secant squared x. Come over here, I didn't finish this. It's du divided by secant squared x equals dx. So you're really integrating u to the second du. And since you are working with u, you have to change your limits. So I'm going to come up here and say u equals the tangent of pi over 4, and u equals the tangent of a negative pi over 4. And the tangent of pi over 4 is 1, and the tangent of a negative pi over 4 is a negative 1. So you are integrating from a negative 1 to a positive 1. You still have to integrate u to the third over 3 from a negative 1 to a positive 1. So 1/3 minus a negative 1/3 will give us 2/3. And those are all the notes for 7.2. We basically did the same thing over and over again, but with lots of examples.